Okay, so let's move on to a new topic called polynomial functions. First, let's look at a definition. A polynomial is a finite sum of terms in which all variables have non-negative powers. And then there's a word of caution here, so I'll get to that in a moment. But it says a polynomial is a finite. Finite means, yeah, a limited number, right? And by the way, the limited number could be 10,000. It just can't be infinite, right? So it's got a concrete amount of terms in which all the variables have non-negative powers. Now, the word of caution is beware of variables in the denominator. So, over here, there's two problems, and they're asking me if these are polynomials. So, according to the definition, it's a finite sum of terms. So, finite, there's only how many terms here? Yeah, 2, and I'll get to the definition of terms in a little bit, but yeah, 2 terms, in which all variables have non-negative powers. So I see a variable, and it has a non-negative power, doesn't it? So would this be considered a polynomial? Yeah, number 1 is definitely a yes, it would be considered a polynomial. Now number 2. So I've got a finite number of terms, right? By the way, when they say sum, it could also be difference. So just know that it doesn't always have to be an addition problem. It could be a subtraction problem. Just FYI, okay? So it is a finite sum of terms. Now, all the variables look like, right? They have non-negative power, so all the powers are positive. But see the word of caution? Beware of variables in the denominator. See, you kind of have to remember something. And what you have to remember is you can actually rewrite this last term. And you can bring that x, instead of dividing by x, you can do 5 times x. But remember that exponent is now going to be different. The exponent is a positive 1 here, isn't it? So you're like, hey, we're good, it's positive. But when you bring it to the top, right, when you move it from the bottom to the top, you have to remember what happens to that power. Does it stay positive? You're right, it doesn't. It goes negative. And because the power is now negative, the answer in this case is no. It's not a polynomial. So remember that. That's why this is word of caution here that says beware of variables in the denominator. Because if the variable is in the denominator and you put it in the numerator, the positive power goes to a negative power. Got it? And by the way, it also, there's another reason behind this, and we'll get to it a little bit later, or you may not, or you may get to it in another class. But for right now, I'm just trying to keep it very simple that if there's a variable in the denominator, you can rewrite it in the numerator with a negative power, and then it doesn't satisfy the definition. Cool? Okay, so hang in there. I got some more verbiage regarding polynomials. Okay, so here are some more definitions for us to look at. After I go through them, I'm going to recommend that you pause the video, write these definitions down, and then start, because after you restart this video, I have some examples that we're going to go over based upon these definitions. So let's look at the first definition. Terms. We kind of alluded to it in the last segment, right? Terms are separated by actually addition or subtraction signs. So make sure you understand that, which you kind of do. It was a little bit instinctive, but there's your official definition. Degree, if they ask for the degree of a polynomial, that's the highest power that's on a variable. The types of polynomials, we have monomials. Mono means 1, so it's 1 term. Binomial, bi means 2, so there's 2 terms. And then we have trinomial, tri means 3, which means we have 3 terms. And then the last definition I want to go over is coefficient. Coefficient is the number in front of the variable. So as I recommend, I suggest that you pause this video, you write these definitions down, and then when you restart it, I am going to have some examples for us to work on. Okay, so let's look at these examples. So I'm going to look at the first one. We've seen that polynomial before, and by the way, we've already identified it as a polynomial, correct? Because it has powers that are not negative, and there's a finite number of terms. So we're good. Now let's talk about the type of polynomial it is, right? I need to know if it would be a monomial, a binomial, or a trinomial. Now some of you already have the answer and some of you don't. Here's the deal. If you're going to identify it as one of those three, then you need to know how many terms there are, right? So we have to go back to that definition of terms. What's that definition of terms? Yeah, terms are separated by either addition or subtraction signs. So how many terms do you think you have here? Good, 2 terms, because there's my addition sign and I have something before it and something after it, which means 2 terms. And since it's 2 terms, it is a binomial. Excellent, good job. Okay, now I'd like to know the degree of this. Remember, the definition of degree was the highest power. Good, so I'm looking at the highest power on the variable, which is 2 in this case, right? I am looking for the coefficients. The coefficient is the number in front of the variable. Good, 6 is definitely in front of the x, so that's definitely a coefficient. Now, depending upon the author of the book that you are using, some authors consider that 4 a coefficient. Some consider it a constant. So, let me sidetrack a second. A constant is a number without a variable. Constant means it doesn't change. And since there's no x being multiplied by that 4, it will always be a 4. So technically, that 4 is a constant. But I'm going to tell you right now, for those who are actually in my class, the authors of the book consider that 4 a coefficient. So, you know, there's kind of debates going on which one it is. So anyway, me personally, I call it a constant. But we're going with what the authors of the book we're using in my class say, and they say it's a coefficient. So there you go. Cool? Okay. Number 2, it is definitely a polynomial, right? Because there's a finite number of terms, and there's no negative powers. And I don't have any denominators with an x in it. Good? Okay, so, got to figure out which type. Is it a monomial, a binomial, or a trinomial? That's right, that means you need to know the number of terms. So how many terms? Excellent, 3 terms. I see a subtraction sign and I see an addition sign, and that is separating 1, 2, 3 terms, which means this is definitely a trinomial. The degree of this trinomial? Yes, it's a 2 because the highest power on the variable is a 2, right? The coefficients? Yes, the coefficients in this case are 5, -3, because that 3 actually has a minus sign in front of it, so it's considered negative, and 2. Again, we're going with what the authors of the book are using here. Good? Okay, number 3. Good, that's a monomial. Excellent. Now, this one you have to be careful of when you give me the degree. Because when you have a term that has more than one variable in it, to get the degree, you're going to have to add those powers. So what's the power on the A? 2. What's the power on the B? Yeah, that's a 1, which means to get the actual degree of this monomial, I'm going to have to do 2 plus 1, which equals 3. So this would be considered a 3rd degree monomial. Cool? Okay, and then coefficients. In this case, there's only 1. Since it's a monomial, there's only 1 coefficient, and that is -7. Excellent. Cool? Okay. There's one other piece of terminology that I want you to be aware of, and some of you are probably aware of it already. It's this thing called descending order. When they talk about descending order, they're talking about with respect to the powers on the variables. For instance, I'm looking at my variables, and in this case it's x. And when I look at the powers on the x's, I notice that they're not in descending order. Descending means from the highest to the lowest. I'm noticing this x has a power of 3, which is larger than this x that has a power of 2. So descending order says that positive, because there's a positive sign in front of the 6, that positive 6x to the third must go first, and then the negative 5x squared, and then the positive 7. This is descending order for this trinomial. Good? Okay. By the way, if it had, I don't know, just plus x, it's no longer a trinomial, is it? Yeah. When there's more than 3 terms, they call it a polynomial, because the word poly means many. And let's see about descending order. The 6x to the third is first, correct? The minus 5x squared, and then that plus x, because that x is to the power of 1, and then the plus 7, because the 7 has 0 x's. Cool? Okay, hang in there. We're going to start adding and subtracting these particular polynomials. So stay. Let's look at these directions. These directions say to simplify. Now, when they say simplify, they mean do the operation it is asking you to do. Do you see addition signs? Then you add. Do you see subtraction signs? Then you subtract. Multiply, divide, with me? Okay, now, here's the deal. When you are adding or subtracting terms, I want you to kind of think of fruit. Sometimes food is the better way for us to look at things, right? Because if I ask you to add 2 apples and 3 apples, you're going to tell me, oh yeah, 5 apples. Good. If I ask you to add 2 apples and 3 bananas, it'll be like 2 apples and 3 bananas. Yeah. Or you say 5 pieces of fruit, but you can't say 2 apples and 3 bananas are 5 whatevers, right? Because they're not the same, so you really can't add them. Can't say they're 5 apples. You can't say it's 5 bananas because they're 2 different types of fruit. Well, the same thing is true with terms. When you're adding or subtracting terms, you can only add or subtract things that are the same. You know, addition and subtraction are the easiest operations, but I'm telling you right now, they are the pickiest operations to work with. So, let's look at this first problem. We want to add or subtract things that are the same. Cool? So I'm noticing the first term of 4x squared y. And I see another term that also has an x squared y. With me? So, for some of us, it's not a bad idea to put these over here on the side and say, well, I guess I have some side work to do. So that's a positive 4x squared y, and then I'm minusing 3x squared y, right? What is that going to give you? Yeah, since they're the same, you're going to end up with a 1x squared y, aren't you? Good. That took care of that one. And then I see a positive 2x, but I see another term over here at the end that also has just an x. So I have 2x minus 7x, right? They're the same. Those x's are exactly the same. They're both x to the power of 1. So you got to do 2 minus 7, which is, good, negative 5 x's, right? And then there's this minus 1/2, which doesn't look like anything. So here's the deal. We have, and this 1 in front of the x squared, that's a multiplication problem, isn't it? Because technically that's 1 times, right? So because it's 1 times, we usually don't write the 1. So we're going to have x squared y, that was the first problem we did, minus the 5x, and then minus the 1/2. With me? Okay, now, the question you have, I'm sure, is, would that be considered descending order? Because as I mentioned before, right, we put things in descending order. We put polynomials in descending order. By the way, it's kind of an unwritten rule. You have to put polynomials in descending order whether they tell you to or not. So FYI. Cool? Okay. So, which letter comes first in the alphabet? The X or the Y? Good, the X comes first. So I have to put this in descending order with respect to the X's. So, we have X to the second written first, x to the power of 1 written next, and then I have a term with no x's. So would that be in descending order? Yes, it would. Cool? Okay. Number 2. I have two polynomials that I'm supposed to be adding together, right? All right. So there's another way of adding things that for adding polynomials that for some of you might be a little bit easier to see. So I'm going to write the first polynomial down. We have an x squared plus xy minus y squared. And I'm supposed to add to it the second polynomial, correct? Well, I'm going to set this up like an addition problem that we learned, I don't know, what, first grade or something like that. And by the way, just because we learned it in first grade doesn't mean that we shouldn't keep utilizing that process. Why? Because we're visual people. And those teachers knew how to teach us because they knew we were visual. So, 2x squared. What does it look like? Yeah, it looks like this x squared because they're both x squares, and I'm going to add the x squareds together. Minus 4xy is going to go under this xy, the 1xy, because I'm going to add things that are the same. And lastly, plus the 7y squared, because it's going to be added to the 7y squared, and I'm supposed to add these guys together. Cool? By the way, what's the number in front of that x squared? Good, 1. So 1x squared plus 2x squared? Good, 3x squared. 1xy plus a negative 4xy? Good, negative 3xy, and then negative 1y squared plus 7y squared, that's a positive 6y squared. Does that make sense? For some of you, this actually might be a nice setup. You might be that visual of a person that you're like, you know, I kind of like that. Use it by all means. By the way, is my answer in descending order? There's two variables there, right? There's x and y. Which one comes first in the alphabet? Good, the x. So is it in descending order with respect to x? Yes, it is. Because there's an x squared, an x to the first, and then no x's. So we're good to go there. Cool? Hang in there. Got some more problems. Okay, so let's look at this third example. Notice they're saying subtract this parenthesis from this parenthesis. Correct? So I have a subtraction problem. Got it, because they said subtract. My only question is which parenthesis is supposed to come first. I don't really care what's in the parentheses. I really don't care what's in the parentheses. What I want to know is which parenthesis do I write first? Do I put this parenthesis first because they wrote it first? No. They said subtract this from the second one. The first one is being subtracted from the second one. So which one has to get written first? The second parenthesis has to get written first because I'm taking the other one away from it, so to speak. With me? Okay. So this first parenthesis is being taken away from the second parenthesis. This is being subtracted from this one. Does that make sense? Okay. Now, here's the deal. Notice the subtraction sign in front of the second parenthesis. Does that subtraction sign belong just to the 6x squared, or does it belong to both of them? Good, it belongs to both of them. So here's the deal. We're going to have the 4x squared plus 2x, right? Okay. And this minus sign, does it go to the 6x squared? Yes, it does. Right now the 6x squared is positive, but when I subtract it, it's going to be negative. So I have a negative 6x squared to put under the positive 4x squared, don't I? Good. But this minus sign also belongs to that negative number, doesn't it? So when you subtract a negative number, yeah, you're supposed to actually add it, aren't you? It's almost like distributing, multiplying it. With me? Okay. Again, this minus sign being in front of this entire parenthesis means everything in this parenthesis is going to get that minus sign. So the minus sign goes to the positive which makes it negative. The minus sign also goes to the minus sign, which makes it positive. Here's the real problem I'm supposed to work on. So, what do we get when we combine these two together? Good, we get a negative 2x squared plus 5x. Wonderful. And is that in descending order? Yes, it is. Awesome. Okay, let's look at problem 4. So the first one's good to go, right? But you notice in front of this second parenthesis, there's a minus sign again, isn't there? All right, so it's time to rewrite the problem. The terms that are on top, they're fine because there's no minus sign in front of all of them. So I'm just going to rewrite them. It's a good thing I changed that x back to a y. This minus sign, it goes with the first term. So when you're minusing a negative or minus a minus, makes it good, positive, right? And this minus sign also goes to this positive 6y, which makes it good, a negative 6y. And this minus sign going to a positive 7 makes it a minus 7. Now that problem is much easier to deal with. My recommendation is to always take care of that minus sign that's in front of the parenthesis first. Because I'm going to tell you right now, parentheses hide the real problem. And when I can get rid of the parentheses, I can see the real problem. And now this problem is very easy to manage, isn't it? So what do we get? Good, we get a positive 7y squared minus 12y minus 3. And is that in descending order? Yes, it is. Just like this one, right? Cool. Hang in there. Got a couple more examples for us. Okay, so let's look at this next problem. We're supposed to subtract this parenthesis from the sum of this one and this one. Well, this one problem might as well be two, correct? So let's kind of pick this thing apart. Because if they wrote the problem out with all the pluses and minuses in it, easy peasy, we could do it very quickly. But when they put it in words, some people have a little challenge with the words. So let's talk. First thing it says, subtract this parenthesis from something else, right? So you know you have a subtraction problem. And where does this first parenthesis go? Before the subtraction sign or after it? Remember, it says subtract this from. Good, it goes after it. So I know that I'm going to have a subtraction sign, and after the subtraction sign will be the 3x plus 7. Does that make sense? Good. And then I'm supposed to subtract this from a sum. What does the word sum mean? Yes, it means an addition problem. So I know I have an addition problem here. And what am I supposed to be adding? Good. This second parenthesis and the third parenthesis. Now, mind you, the word and does not mean add, subtract, multiply, or divide. The word and tells you that you're going to keep these two guys together and do whatever operation they want you to do between them. Good? Okay. So, this first parenthesis, I'm supposed to take the 7x squared plus 4x plus 9, and I'm supposed to add it to this one, right? But do you notice this parenthesis is not in descending order? Yeah, so what do you think we should actually do before we write it? Good, let's put it in descending order. So we have x cubed first, then plus x squared, then plus 7x, and then minus the 8. Excellent. Y'all with me? Okay, so I am going to take care of adding these two guys together first. Why? Because that's what we wrote first. So we have 7x squared plus the 4x plus 9, and I'm adding to it x cubed. Well, there's no x cubes here, are there? But it should come before the x squared, right? So I'm going to put x cubed here in front of the x squared plus 8x squared under the x squared plus 7x under the x, and then minus 8 under the 9. So I'm taking care of these two guys first, and we're supposed to be adding them. So what do we get? Good. This would just be x cubed. Excellent. Plus 15x squared plus 11x plus 1. Okay. So this is the result of adding these two parentheses together. And then what are we supposed to do? Yes, after we add the first two parentheses, we're then supposed to do what? Subtract that third one, aren't we? All right, so we have x cubed plus 15x squared plus 11x plus 1. And now we're supposed to subtract this guy, aren't we? Okay, how many terms are inside? 2. And there's a subtraction sign out front. So does that subtraction sign just go with the 3x? Great, good job guys, it doesn't. It also goes with that 7. So this 3x is what sign? Good, negative. And what do I put it under? Yeah, x goes under x, so it has to go under the 11x. Because those are both just x's, right? And then that 7 is what sign? Good, minus, negative. And it goes under the 1 because the 1 doesn't have an x and neither does the 7. Cool? All right, let's take care of this. So we have x cubed plus 15x squared. Excellent. Plus 8x minus 6. Wonderful. So did we do everything they asked us to do? Did we add the first two parentheses? Yes, we did. Here it is. Did we take that answer and minus the third parenthesis? Yes, we did. So here is your final answer. Cool? Hang in there. Got a couple of examples. Okay, so here's a blast from the past for us. They say if p of x equals x squared plus x plus 1, and q of x equals 5x squared minus 1, they'd like us to work these two problems out. We've seen this before, so this should be nothing new for us. So let's take a look at the first one. They say find p of 7. So which function do I look at? The p or the q? Yeah, we're going to look at the function p. So they want p of 7, right? So what did 7 do? 7 took the place of x. So this is equivalent to them saying, let x equal 7. Are you with me? Okay, so x squared, but instead of x, I'm supposed to write 7. So I'm supposed to have 7 and square it. Plus 7, and then plus the 1, right? Okay, so 7 squared, 49, plus, yeah, that's just going to be 7. And then plus 1, okay, stay off the calculators. What do you guys get? Good, 57. Excellent. So p of 7 is equal to 57. Cool? Okay, let's look at the second one. What did negative 10 take the place of? Yep, I'm looking at the q function because it says q and it took the place of x. So this basically says let x equal negative 10, doesn't it? All right. So q of negative 10 equals, what do we write first? 5. And it's supposed to be 5 times, right? So in this case, 5 times what? Yeah, the negative 10, which is supposed to be squared. Because I'm supposed to square the x, so I'm squaring that negative 10. Just like I squared the 7, right? And then we minus the 1. Agreed? Okay, so order of operations, what comes first? Multiplication? Exponents or subtraction? Exponents. So I have to do negative 10 squared, which is 100. And then I get to do the multiplication. Good, 500. And it's supposed to minus the 1, which gives you 499. So q of negative 10 equals 499. Cool? Okay, so you guys have fun with this stuff, and I'll catch you on the flip side.